New pictures captured by the James Webb Space Telescope have shocked scientists. Rather than confirming our view of the universe, these pictures have uncovered an unsettling reality. Our continuous cognition is lacking in making sense of the universe's early stages. The prevailing theory of the universe's beginnings appears to reach its limits, forcing us to consider new hypotheses about its early formation. The question arises: how was the universe shaped in detail and why? This new discovery challenges even the most experienced astronomers to learn more about the Big Bang and its ever-evolving intricacies. We must reassess the possibility of the Big Bang itself. Contrary to popular belief, the Big Bang was not an explosion in pre-existing space. Rather, it was space itself that began to expand approximately 13.8 billion years ago, along with matter and time, from an exceptional phenomenon in physics and cosmology. A singularity describes a point where gravity is so extreme that the curvature of spacetime becomes infinite. Today, after billions of years since the universe's inception, we observe that our cosmic home is part of a vast network of celestial interactions. For scientists, this represents a fundamental aspect of the universe, as its constant evolution is crucial to understanding its nature. The universe is not expanding into pre-existing space. Rather, space itself is continuously growing. According to traditional theories, the first stars began to shine between 200 and 300 million years after the Big Bang, marking the end of the so-called Dark Age. This was when the first luminous celestial objects clustered together to form mature galaxies. However, how quickly these galaxies evolved remains an ongoing mystery. A significant discovery emerged from the first images received by the James Webb Space Telescope in July 2022. Scientists reported that the telescope had identified various galaxies, some of which existed around 300 million years after the universe's formation. Compared to the galaxies that formed billions of years later, these early systems were much smaller and less massive. This observation aligned with the accepted scientific model, which suggests that the density of matter in the young universe was not sufficient to produce galaxies of the size we see today. However, the discovery of 6 astonishing redshifted luminous spots in Webb's data triggered one of the most significant cosmic crises in recent times. While these newly found galaxies are similar in age to previously recorded ones, they are almost as large as our own Milky Way galaxy. This has created a puzzling contradiction in Big Bang cosmology. Upon further analysis of images captured by the near-infrared camera, scientists identified these light sources and, using redshift measurements, confirmed that the light from these objects had traveled for more than a billion years to reach Earth. This means these structures had already existed between 570 and 700 million years after the Big Bang. Surprisingly, these galaxies were so large that they defied traditional cosmological models. Instead of finding the expected dwarf galaxies, astronomers detected structures nearly as vast as the Milky Way. If we continue to analyze the data gathered by the James Webb Space Telescope, it appears that this gravitationally bound collection of stars already had more than 10 billion times the mass of the Sun at that time, with one potentially reaching an unimaginable 100 billion solar masses. However, even if this possibility is considered, the mystery remains unresolved. This scenario would imply a far greater mass in the early universe than previously expected, presenting a major challenge to conventional cosmological theories. Even if only one of these galaxies proves to be real, it would force a reassessment of our fundamental assumptions. To explain their existence, the density of matter in the early universe would have to be several times higher than current models predict. Another equally perplexing explanation suggests that these galaxies formed through an unknown process. These revelations and the debates they have sparked will inevitably lead to a reassessment of the Big Bang theory. Many scientists with alternative perspectives express frustration, but their views are often dismissed or marginalized in scientific discourse. Even those who continue to support the Big Bang theory face unresolved questions. These include fundamental inquiries such as: why and how did the universe emerge from nothing 13.8 billion years ago? Could something truly arise from nothing, or was there a triggering event? Was it all a cosmic accident? Stephen Hawking once suggested that time itself began with the Big Bang, meaning the process could not have been initiated by an external cause. A related question concerns the uniformity of radiation and matter distribution throughout the universe. Regardless of direction or distance, observations reveal a consistent pattern in the cosmic structure. Modern scientists explain this through the theory of cosmic inflation, which proposes that the universe underwent rapid expansion moments after the Big Bang. However, some researchers extend this idea further with the theory of eternal inflation. According to this concept, inflation may have ceased in certain regions, creating bubbles while continuing indefinitely elsewhere. This raises the possibility that other universes exist within these bubbles, each with its own distinct physical laws. If this is true, then our universe may not be the entire reality. Instead, it could be part of a larger cosmic cycle. Some alternative theories even suggest that the Big Bang was not the beginning, but rather part of an ongoing sequence of cosmic expansions and contractions. Others propose that the universe has always existed in some form, eliminating the need for an initial moment of creation. Another provocative idea emerges from quantum physics and string theory, which hint that our universe might be a higher dimensional projection or even a sophisticated simulation. While this may sound like science fiction, some physicists consider it a plausible explanation for certain quantum phenomena. A Type 3 civilization, one capable of harnessing the energy of an entire galaxy, could theoretically create such a simulation. However, proving or disproving this theory remains an immense challenge. Exploring the origins of the universe inevitably leads to profound mysteries. The latest images from the James Webb Space Telescope have reignited debates about fundamental cosmological concepts. The discovery of early galaxies that appear more massive than expected forces scientists to reconsider the timeline and mechanisms of cosmic evolution. One of the central questions is the nature of cosmic inflation. According to the prevailing theory, inflation occurred within a fraction of a second after the Big Bang, causing the universe to expand rapidly. This explains the uniformity of the cosmic microwave background radiation. However, Webb's discoveries introduce complexities that may require modifications to inflationary models. The presence of massive galaxies so soon after the Big Bang also raises questions about the role of dark matter and dark energy. Dark matter is thought to provide the gravitational framework for galaxy formation, yet its properties in the early universe remain poorly understood. Similarly, dark energy, which drives the accelerated expansion of the universe, might have played a role in shaping these newly discovered galaxies. As the James Webb Space Telescope continues to gather data, its findings may revolutionize our understanding of the cosmos. Some scientists speculate that our universe is merely one of many, each with unique physical properties. Others consider the possibility that the universe exists within a larger unknown structure that operates on principles beyond our current comprehension. The implications of these discoveries extend beyond physics and astronomy. They challenge our understanding of reality itself. Could we be living in a simulated world? What if the universe is part of an endless cycle of creation and destruction? Regardless of the answers, one thing is certain. Our quest to understand the universe is far from over. With every new observation, we push the boundaries of knowledge, uncovering deeper truths about the cosmos and our place within it. The James Webb Space Telescope is not just a tool for astronomy, it is a window into the deepest mysteries of existence.